2.5. Ha, 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 ha. 2.5.
I'm out of breath. I should never try to do that in one breath.
Let's just start by solving triangles instead.
Okay, and then maybe we can do some problem solving after. Huh, we have great ideas. So, what does it mean to solve a triangle? Well, if I were a betting man, I would bet that it means that you want to find the measure of every single side and every single angle.
Ooh, I'd put my money on that too.
Yeah, we're gonna make some cash on those bets, for sure. So whenever we're given a right triangle, we know we need to use trig to find out any other information. Remember, we're always given two other pieces of information. So not just that it's 90 degrees, but we need at least one side length, and then another piece of information which could be an angle, or it could be that we have two side lengths. As long as we have that, we can find out anything else about that triangle. And as said just a moment ago, we want to find every single side, every single angle. So whenever you see the solve for a triangle, then make sure you're finding all of that. We're given some measures. It is recommended that you use those as much as possible. So as we find stuff, we will have more options, but stick with the original measurements as much as you can just to maintain accuracy. And in terms of what variables we use, we can't just start saying, well, this is theta and this is theta, because that's two thetas. How can theta be two things at once? And we can't say that this side is x and this side is x. No. The same variable can't represent two things. However, given that this is labeled as A, B, C, the sides will also have same names. Whoa. So across from angle A will be side A. Across from angle B will be side B. And across from angle C will be side C. Do make sure that you are labeling those sides accurately, because if you're not, that would be bad for the overall mark. How did that X just pop up out of nowhere? That's fine. We have options here. There are so many things that we could choose to find if we choose to. Wherever you start, it doesn't really matter as long as you eventually find the three things that we're missing. Because we have side B, we have angle A, we have angle C. We don't have angle B. There's one angle we're missing. There's two sides we're missing. So let's check those all off one at a time. We're going to round nearest hundredth of a unit for all of our final answers. Personally, I'm going to start with angle B. And for that, I can use the rule that the sum of the angles of a triangle will be 180. So if I take 180 degrees and I subtract the 90 degrees from angle C, and I subtract the 53.1 degrees, that's angle A, I'll get angle B. And put that all in there, we're getting 36.90 degrees. I need to find C or A. Again, doesn't really matter which one I choose first. I'll go with A. So I'm now going to find A in a different color just to separate the stuff here. And for this angle that I know, we've got opposite and adjacent. I'm going to play with tan. Tan of angle A will be side A over 3.33. Actually, yeah, sure, I can say that. So tan of 53.1 is A over 3.33. A is 3.33 tan of 53.1 degrees. Don't forget that. Which gives A a value of, according to the calculator, 4.44. Oopsie daisy, that's not the tool at all. Last thing we need to find is B. Or no, C. And for that, I'm going to use cosine. I'll say that the cosine of angle A is the adjacent side for that angle over the hypotenuse. I can specifically say that cosine of 53.1 degrees is 3.33 over C. Thus, C is equal to 3.33 divided by the cosine of 53.1 degrees. And for that, I get a value of 5.55. I do a quick check for units. There were no units in the original measurement, so I don't need to worry about units here like meters or inches or any of that. I have found all three things I am looking for, so I can say that this one is DU and done.
Okay.
I've never learned how to spell.
That's why we teach math. All right. Next question here. We have a triangle TUV, and we have some of that information, but not all of it. So, of course, we are missing both of these angles, angle T and angle U. We are also missing side length T, but we are given side length U as well as side length V. Remembering, like Mr. Thide said, that the side length opposite a particular angle gets the same name but is just denoted in lowercase. So lower cases represent side lengths and upper cases represent angles. All right. Now, what I might do to start is we can actually use Pythagoras to solve for side length T, right? Because we have 2 out of 3 sides in a right angle triangle. Keep in mind that it actually doesn't matter what you start with, as long as you start somewhere. And what Mr. Thide said before was we want to always use that information provided to us. So I'm going to use Pythagoras to solve for T. I know that 16 squared plus T squared is equal to 26 squared. And 16 squared is 256. T squared, je ne know pas. And 26 squared is 676. We want to subtract 256 from both sides to isolate our T squared. So we end up with 420 is being equal to T squared. We square root both sides to get our T alone, and we end up with T equals to 20.5.
Means that hundredths above.
Oh, does it say hundreds? Oh. Well, in that case, my bad. I believe that is 20.49. Oh. My bad there. That is 20.49. Perfect. Now that we have all of our side lengths, we have to find one of our angles next. And we could find angle T or we could find angle U. It's kind of up to us. I'm going to go for T because T for Thibodeau. Looking at my angle T and wanting to use that information that was originally presented to us, I have my adjacent and my hypotenuse. My adjacent and my hypotenuse. And because I have my adjacent and my hypotenuse, I'm going to use the trig ratio cosine. I know that the cos of angle T is equal to my adjacent over my hypotenuse. I don't have to write adjacent and hypotenuse if I don't want to. I can go jump straight into cosine of angle T. It's going to be 16 over 26. To uncos my cos of T, I'm going to inverse cosine both sides. So I'm left with T is equal to the inverse cosine of 16 over 26. And when I beep boop bop that into my calculator, I end up with 52.02 degrees. Now, I could very well at this point take my 180 and subtract my 90 and subtract my angle T to find my angle U. However, if I made a calculation here, it's not going to provide me the most accurate information for angle U. So we are going to continue to use that information provided to us to solve for angle U, just to kind of be on the safe side here. Oops. So to go ahead and do that, according to my angle U, my 16 is considered my opposite, and my 26 is considered my hypotenuse. If I have my opposite and my hypotenuse, I'm going to use the trig ratio sine. Sine of angle U is my opposite over my hypotenuse, or sine of U is going to be my 16 over 26. To undo sine, I inverse sine both sides, so I get U is equal to the inverse sine of 16 over 26. And when I beep boop bop that into my calculator, I should get 37.98 degrees. And if I wanted to just kind of do a mental double check of my work here, I should, that did not highlight as expected. I should see that my angles should sum to 180. So 52.02 plus 37.98 plus 90 should in fact give me 180, and it does. So that's a nice little mental check that I could do to make sure I've kind of done all my work correctly. The other thing I might want to check is that my largest angle corresponds with my largest side, and my smallest angle corresponds with my smallest side. So just for the sake of maybe indicating that all here, I'm going to get rid of this green stuff. And I'm going to write down those values just so that we could see them there. So I have 20.49, I have 37.98 degrees, and I have 52.02 degrees. Well, my biggest angle does in fact correspond with my biggest side length, and my smallest angle does in fact correspond with my smallest side length, which means my medium also corresponds with my medium. So those are some good mental checks that we could do to make sure that all of our answers are reasonable and make sense. I have in fact now solved for all of my missing sides and angles. I can check to make sure I've included units where necessary. My side length doesn't have a unit in my question, so I am good to go. And that's it. That's all for this question.
So that's it with solving triangles. We are going to do a little bit of problem solving as well. Kind of related to how we had some diagrams we had to play with earlier in last lesson, but getting a little bit more involved. Like this one has a particular set of 7 steps that spans 210 centimeters diagonally, rises at an angle of 30 degrees. What length of carpet would be needed to cover them to the nearest whole centimeter? Just so we're clear, when you have 7 steps, like there's 1, 2, 3, 4, 5, 6, 7, people don't just lay on a roll of carpet like this and say, well, we done. No, they're going to carpet the top and the front of each step as it goes down. So we do same. The span of this is 210 centimeters diagonally, so from the base to tip here, we're looking at 210 centimeters. And it rises at an angle of 30 degrees. So relative to this horizon, horizontal line, about a 30-degree angle, what length of carpet do we need to cover them? There are a couple ways to approach this. One is to note that if we took all of these lengths and added them up together, well, we'd get this total line down here at the base. And similarly, if we took all these parts of the stair that we kick on the way up accidentally and trip and fall, we add all those up together, and then we get this whole height over here. So we could find this value and this value, add them together, boom, there's carpet. Other way you can approach this thing is to look at just one step and say that one step would span not 210 centimeters, but perhaps just 30 centimeters. We divide it by 7. And then we could find, if this is 30 degrees, this is 30 degrees, we could find the two parameters for a single step, add them together, multiply by 7 to go with all of the steps. I'm personally going to go with the first method. You choose whatever your heart desires. And I go. I'm going to call this side X. I'm going to call this side Y. And hereabouts, I will then say cosine of 30 degrees is equal to adjacent X over 210. X is thus 210 cos 30 degrees, and X has a value, where's my calculating device? Got it. 181. Now it says to the nearest whole centimeter, but I'm not done yet, so I'm going to keep some extra decimal places. I usually go 2 to 3 extra just to be safe. I only need this to be rounded to the whole centimeter at the end, so 2 to 3 extra, I should be okay. Now I'm going to get also this y value, and that's my opposite side, so I'll say that the sine of 30 degrees is y over 210. Y is 210 sine 30 degrees, therefore y is, quite precisely, 105 centimeters. So the length of carpet is going to be x plus y, and for us that gives us 286.87. Let's answer this with some words. Let's make sure that we round to the nearest whole centimeter, and we can say that the required carpet length is 287 centimeters if we're going to the nearest whole value. Cool beans?
Cool beans, Mr. Wright.
Darn right it is. Thanks, students.
Alright, last but not least, we want to determine the area of the isosceles triangle below, and we want to express our answer to the nearest tenth. Now, when we are looking for the area of any triangle, we know that the formula is my length of the base times the length of the height divided by 2. Or you could say 1/2 base times height. Well, the height extends down from the tip or top of my triangle all the way straight down to the bottom. And then as it does so, it creates a right angle with my base. So as we might see, is we actually have two right angle triangles kind of put together to create this isosceles triangle. Okay. So that's kind of neat. We need to determine a couple of things. We need to determine the height as well as the base so that we can calculate the area. Now, to do that, well, there's some work that needs to be done first. Let's take a look at one of the individual triangles here. If this whole top part was 30, and we're splitting it up into two equal right angle triangles, well, this angle here must be 15 degrees. The side length still stays the same at 20 meters. Now, we can find our height of our triangle of our isosceles, it'll be the same as the height of our triangle for a right angle triangle here. And we can find this value as well. I'm going to call it x. I'm not going to call it b because that's not the complete base, but just half of it, right? Because if these two triangles are equal, then both of those bottoms of my right angle triangles will be same, and my base will just be x plus x. So I could go ahead and find this value in this triangle as well. So let's get it started. Alright, so to kick things off, I don't know, I feel like solving for h first. Personal preference, I guess. Alright, so I am given this angle here. According to my 15 degrees, my 20 meters would be considered my hypotenuse, and my height, h, would be considered my adjacent. So I'm going to use my trig ratio cosine. So I know cosine of 15 degrees is my adjacent, which is h, over my hypotenuse, which is 20. To isolate for h, I'm going to multiply both sides by 20, getting 20 cosine of 15 degrees equaling h. And when I beep boop bop that into my calculator, I end up with h being 19.319 meters. And I'm going to keep a couple of extra decimal places just because if I want to round my answer to the nearest tenth, if I round too soon, I might introduce error into my calculations down the road. So I always like to keep at least 2 more decimal places than what my final answer requests. Alright, so I found the height. I could also go ahead and find my value of x. And according again to that same 15 degrees there, x would be considered my opposite, where 20 is still considered my hypotenuse. In the case of finding x, I'm going to be using my sine ratio. And sine of 15 degrees is my opposite, which is x, over my hypotenuse, which is 20. To isolate for x, I'm going to multiply both sides by 20, leaving me with 20 times sine of 15 degrees equaling x. And again, when I beep boop bop that into my calculator, I end up with 5.176 meters. And if I would like, I can go ahead and label that on my triangle that I've started with to help me kind of visualize where those numbers belong. So I know that my height is 19.319 meters, and my value of x there would be 5.176 meters. Now, like we said before, when I'm trying to find the area of my triangle, I need the base side length there. And the base side length spans right across the bottom, so if half of it is 5.176 meters, I know that the whole of it is that value added to itself, because it's twice as long, giving me 10.352 meters. Now, I am super stoked because I have all of those measurements required to solve for my area. And in doing so, that's kind of a messy A. In doing so, I can go ahead and plug in. So I know my B would be 10.352. My H would be 19.319. And those would multiply and divide by 2. And when I go ahead and do that, I should end up with an area of 99.995144. My units for my area are meters squared, but wait, I need to make sure my answer is rounded to the nearest tenth. Now, if I'm rounding my area to the nearest tenth, I know I'm going to have to round that up, which means I would have to round that up, which means I'd have to round that up, which means I get 100.0 meters squared. And again, if I am starting a word problem here, I should probably answer my problem with words. So the area of this isosceles triangle is 100.0 meters squared. Whew, baby.
That was a doozy.
Alright, so there's some practice questions at the bottom here for you to check out in the textbook. Yes. Otherwise, that's it. That's all. Peace out, home slices. Home loaf.
Home skillets.